this very interesting discussion that you just had. It entirely focused on a kind of political, social action, at the political level. And I think I'm going to bring you back a few steps from here into some more fundamental information that will actually reinforce very much what we've been talking about, but I think give it a firmer basis in terms of being able to speak about your concerns with real conviction about the effects of marijuana on the brain. And you'll hear from Dr. Ford in a few minutes about the phenomena of the brain and the body as well. People always ask about what the credentials are when they go to do something. And so this is a quote of mine from the Washington Post. When I was working at the National Institute on Drug Abuse, during the time of the Just Say No campaign, almost got me fired. So I'm here to tell you that I'm repentant. Actually, the real quote was this. It was about whether he would die from a marijuana overdose or not, which as far as I know, has never been done. But since then, things have really changed. I went to the National Library of Medicine database for scientific publications and just did a quick search on marijuana and 7,500 scientific papers on marijuana, 16,500 on cannabinoids. Cannabinoids are the chemicals in marijuana that give it its psychoactive and other effects. 12,000 for medical marijuana, which is quite astounding since the federal government has virtually no money, if any at all, funding research on medical marijuana. And in addition to that, we have studies of endogenous cannabinoids, that is, the cannabinoids that are in our brains and in our bodies naturally. And we understand now that these play crucial roles in many functions that are just really important. One is brain development. Cannabinoids help guide the development of the brain. Cannabinoids modulate communication between neurons. And so they may strengthen or weaken these communications depending on the situation. And they were involved in all of these different functions you see here: memory, movement, appetite. Drug companies are really into the appetite thing. Pain, there's lots of drug companies spend a lot of money trying to develop cannabinoids as analgesics, hasn't been successful so far. But we have all of these functions, and in adults, in a few places in the brain, you know that new neurons are being formed, and cannabinoids also help regulate these. So there is a role for endogenous cannabinoids that is very important in how the brain works. And obviously, when you're smoking marijuana, you can affect this to some extent. And so here we are, marijuana could be legal. What's the big deal? We've got alcohol already, we've got tobacco, and certainly marijuana is not any more dangerous than they are. So you're told by some people. We have prescription medications, which are now killing more people than car crashes. So what should be our safest drugs are now turning into our most dangerous. So why is this going to be a big deal? Well, this is why. One of the most important factors in drug use and drug addiction is availability of drugs. When you're around, people use them more. Conversely, if they're not around, people can't use them. And it's 100% for sure that if marijuana becomes available in retail outlets or whatever, that kids are going to get it. I mean, we've pretty much proven this with alcohol and tobacco, how good we are at regulating things in that of the hands of our children. And marijuana has profound effects on the developing brain. And when I talk about brain development, I'm not just talking about what happens in utero to a fetus or right afterwards to a baby who's 1 or 2 or 3 years old. Adolescence is a very important time of brain development. And marijuana can have profound effects on the brain during its development in adolescence. So let's talk about this. And one of the things I want you to understand is that when we talk about the brain, we talk about the organ that controls our development. It's the workings of our brain that are our conscious mind. That's part of the evidence you have that your brain is working. When you decide to reach for a glass of water or scratch your nose or whatever it is, it's your brain that's guiding all of those actions. And some of the things that we do are pretty automatic, like I'm able to stand up while I'm talking without thinking about it. That's a good thing. But lots of our actions are intentional. What I say in the next few moments are things I decide to say. And it's the intentional actions that in many ways are the most important ones. And we learn to come into control of these intentional actions. We learn to control our behavior. As we develop through childhood and adolescence, and this is due to the maturation of the brain. Infant child brains are just not as mature as adult brains, and our behavior shows it. And then we know, as I said a moment ago, adolescence is this crucial period of brain development, and that environmental factors play a huge role in what happens to the brain. Again, we know this. We know kids who grow up without the proper nurturing in difficult environments are going to have a much harder time later in life. We know that how we deal with our children is in a really important way for how they're going to be as adults. And we know that taking drugs changes the environment of the brain, and so will change the outcome for kids who are drug users early in life. When I say environment, I mean taking drugs, and I also mean the other things that we do to our children, how we teach them, if they go to Head Start or not, if they have good schools, or when they get to school, are they hungry? All these environmental factors affect how the brain develops. And in humans, adolescence is a really long period of time. It's basically from about age 12 to about age 25, if you look for the end of the brain development. Begins with the onset of puberty and basically ends when we have a whole bunch of rights and responsibilities that are considered by others to be able to take care of ourselves in a proper way. Now, it turns out we start to confer these rights a lot earlier than 25, but that's when the brain finishes developing mostly. So in childhood, as you all well know as their parents, the behavior of children is basically driven by what they need and what they want right then. They don't think very much past. They're hungry, they're scared, they're tired, or whatever. But as adults, we know that our behavior can be driven by rational thought. We're not controlled completely by our emotions and our physical needs. And this development, as I said, takes about 25 years. And so getting from here, this little child who I don't know what her problem is, but she's sure got a big one, to this group of young medical students who are putting off a whole array of rewards and good things in order to study medicine, which takes, once you get out of college, another 10 or 12 years before you're really fully certified for practice on your own. Who are putting off all these pleasures to work for a very distant goal. And working for distant goals is one of the real markers of adulthood. And so, what I'm here to tell you is that this ability to do that, to put off your desires, what you want right now, what's fun right now, to work for something in the future, to do the maturation of the brain, a part of the brain called the prefrontal cortex. So, here's a little cartoon. You can't even see this point, okay? Here's a little cartoon of the brain, and it's this area that's lit up here, which is the very front of the brain. It's the part right behind our forehead, right in front of our eyes, called the prefrontal cortex, which is the key to a lot of our higher cognitive abilities, especially in terms of controlling our behavior, allowing us to act, if you will, like adults. And this image is one of the most famous images in the neuroscience of human development, because what it shows is a series of MRI studies looking at the development of the brain over time. And what you see back here, at around 5 years of age, with all this yellow and red, are showing parts of the brain, and what you can see in the cerebral cortex. By the way, the prefrontal cortex is right here, or if you will, it's right here. The yellow and red parts of the brain are not mature. And as you get more blue, and especially purple, you have a more mature brain. So from this series of studies that took place in children funded by the National Institute of Mental Health, by the way, over many, many years, obviously, we see the development of the cerebral cortex over time. that allows us to go from, a crying child to a thoughtful adult because of how our brain is developing. And along the way, each of these, they're not really steps, it's a continuum. The environment is having a big effect on what happens. And so what actually happens in the brain matures? So, in a single word, it's pruning. We look at this picture, this image of a tree here, and we see it has lots of branches with lots of little branches, and after it's pruned, we see there are far fewer branches. When you do this to a tree, it really flourishes. It actually starts to grow new branches, it gets stronger, and the parts that are left are functioning better. So now, let's take a look at a real neuron, a nerve cell in the brain. And you can see the one on the left here is very complicated. All those tiny little bumps that you can barely see are places where it communicates with other nerve cells. And so this would be what a nerve cell might look like in a child, whereas over on the right side here is an adult nerve cell. And as you can see, it's far simpler. It has less processes. And it has been pruned. It's been pruned by experience. The inputs that occur to it a lot preserve the structure, and the ones that don't work so well, don't happen so often, they disappear. So what's left is more highly functional. And so, how does this really work? So, when you think about how the brain works, a good way actually to think about it is as if you were in a meeting. And in terms of children, you're in a meeting when everyone's talking at the same time. So we have this nerve cell here in blue, and it wants to communicate with this other one here in gold. And in children, there's lots of competition on this neuron for inputs, right? It's hard to, the neuron is being influenced by all these other neurons. But through the process of pruning that takes place during adolescence mostly, a lot of the other nerve cell connections are wither away because they're not used, whereas the ones that are used a lot remain and become stronger. So this is basically what we see on the right here. So this pruning process strengthens communications for connections that are used a lot. And the result of that is that the brain, the cerebral cortex, actually gets thinner as we mature. And a thinner cortex is a more efficient cortex with stronger connections that allows it to work better. And as we'll see in a moment, this is really important because this thin prefrontal cortex, along with the thinning of the rest of the cortex, allows the prefrontal cortex to control our behavior better. There's not so much noise going on everywhere else. The prefrontal cortex can say, do this, and the rest of the brain will actually listen. All right? So this is brain maturation and pruning of connections so that there are fewer. There are other things that happen as well, and I think Dr. Friedman mentioned some of them to you in addition to this. So this image that we saw here is actually an image of the thinning of the cerebral cortex. And one of the things you can see is that as you watch development, areas of the brain, so this is the front, that's the back, this is the front, and this is the back. The areas of the brain that mature first are in the back of the brain. They have to do with sensing the world and control of movements. You think of a 12-year-old, 14-year-old gymnast on a balance beam, right? They can do that at 14 years old, and in fact, they go up on a balance beam with not too many qualms, whereas a 20-year-old might look at the balance beam and say, you gotta be kidding. So the back of the brain is maturing first, and the front of the brain is maturing last. The prefrontal cortex is the last thing to mature. And maturation has to do with strengthening certain connections. So when we look at this behaviorally, what do we see? We saw the little baby, we know what's controlling her behavior. But when you get to about 12 years old, rational processes start to kick in. So around that age, around the onset of puberty, children are able to move from a really sort of concrete here and now type of thinking to a more visually oriented, logically oriented kind of thinking. That's abstract, that allows them to project into the future and say, if I do this, that will happen. They start to understand cause and effect better. And this continues to develop. And at around age 15, most 15-year-old kids are just as good at making sound decisions about hypothetical situations as adults are. You give them a complex situation, you ask them to figure out, and they can do it, just like we can do it. But we know, how many of you have had teenage children? We know that they don't behave that way. Even though they have the capability for making sound decisions somewhere in their brains, they don't behave as if they have it. The morbidity and mortality rate for teenagers is 200 or 300% more than it is for children on the one hand and 20 to 30-year-olds on the other hand. There's something about adolescence that buries the ability to make rational decisions and instead leads to all kinds of risky behavior. Now, I have to say, when I say stuff like this, you understand it. I'm talking on average. There are lots of kids who start when they're young and they're very rational and clear thinking and do the right thing, you know, and do well in life. And there's other kids who are out of control from the outset, and there's a little bit of use there. But on the average, this is what happens. So why are teens so reckless? I already mentioned one of the reasons is the late development, if you will, or the later development of the prefrontal cortex. But the other reason is that there are circuits in the brain that mediate our feelings of pleasure and well-being. And we call this the reward circuit. It develops far earlier than the prefrontal cortex. And risky behaviors, sensation-seeking kind of stuff, doing roller coasters, jumping off of bridges, taking drugs, whatever it is, driving too fast, having sex when you shouldn't be, all of these activate this reward circuit. And it's a very powerful stimulus. I mean, just think of, you know, what pleasure you've had in life, and this is the reward circuit in action. It's very powerful during adolescence. It feels good then. Avoiding risks, let's face it, is boring. You know, you're going to go study, or you're going to go out with your friends and party. And so there's a mismatch in the brain. There's a mismatch in the brain between the power of pleasure and the ability of rational thought to control our behavior. The ability for rational thought to take over is something that develops as the brain matures and the prefrontal cortex becomes more dominant in controlling our behavior. In addition to this, there's puberty. And while we need the estrogen and testosterone that start to flood the body during puberty, because it provokes the brain to develop, to start pruning itself. At the same time, we also know that high levels of estrogen and testosterone increase behavioral volatility and impulsivity and emotionality. And so we talk about teenagers as a period when their hormones are raised. And that's often an explanation given for why they're so crazy. And it's partly true at least. So we have this mismatch between reward and control, and we have a volatile brain with a hot reward circuit during adolescence. Drug, sex, and rock and roll, right? What do kids want to do? They want to party. And that's showing the predominance of this reward circuit. And helping to explain why risky behaviors are so much more predominant in adolescence than they are in other times of life. So this is just a cartoon showing a little bit about this reward circuit and some of the parts of the brain that are involved in it. And I just want to point out that one of them is the prefrontal cortex. And another one is a place called you read about the brain and reward. You've heard about these structures. The prefrontal cortex is basically a brake, a damper on what goes on down here. When this little circuit is activated, we feel good, we want to do it, we want more of it, and we want to connect. When the prefrontal cortex is active, it's telling these areas to just relax a little bit, calm down, take it easy, have a glass of water, chill out. And so that's what this slide is showing. It's showing the kind of things, this area here prefrontal cortex, and is connected with other regions of the brain. This is currently what the region of the prefrontal cortex will do. Reality testing, let's see, if I jump off the bridge, what's going to happen? Monitoring errors, okay, I jumped off the bridge once, wasn't so cool, I hit the water really hard, I didn't like it. Maybe I shouldn't do that again. Paying attention to one thing versus another, and most importantly, is inhibiting inappropriate actions. It's the prefrontal cortex that says, this is not a good idea, think about it again. So, think about soldiers, for example. Why is it that the Army is really eager to get 18, 20-year-old kids into service? Because when the captain says charge, an 18-year-old says, how fast? If you say charge to a 30-year-old, he says, why? So, and it's because of this little bit delayed, late development of the prefrontal cortex. And another major role in regulating emotions, so they don't get so hot. Prefrontal cortex can't do that. And so, what we have in adolescence is illustrated in this little graph. And what this graph is showing is the maturation in the red line of the nucleus accumbens that form part of the reward system, and the prefrontal cortex, and how well it's functionally developed versus how old you are. And so what you can see is that during adolescence, the nucleus accumbens is developing faster and reaches its peak functional abilities earlier than the prefrontal cortex. There's this gap between the emotional part of the brain, the nucleus accumbens, and the thoughtful part of the brain, the prefrontal cortex. So the nucleus accumbens is more functionally efficient. It's more powerful to control it. This mismatch between intense emotions and our ability to make smart, rational decisions. And so, yeah, kids are volatile, kids are crazy, kids do weird things that they shouldn't do. And part of the reason, a big part of the reason, is their brains are just not mature yet. I mean, it's like, we know this is going to happen. It's entirely predictable that teenagers will make bad decisions. And to treat them as if they're like fully functioning adults when they make these bad decisions is not taking into account what we actually know about how the brain develops. And so when we look again at the prefrontal cortex, like the prefrontal cortex, these are regions in yellow here that are more used by adults in decision making than by adolescents. So if you measure the activity in these areas, and this is actually showing the middle part of the brain, and it's the area that's involved in emotional regulation that adults turn on far more when they're making decisions than teenagers turn on. Teenagers are not regulating their emotions the way that adults do. They're not regulating their impulsivity. They're not regulating what they want and what might be good for them. So who figured this out first? There's a quiz for you. Was it a neuroscientist using brain imaging? Was it the Department of Motor Vehicles? You can get a driver's license at 16, right? That's an adult thing. The Board of Elections, you can vote at 18. That's a very mature thing to be able to do. The Army let you enlist at 18. State Liquor Control Board, you can drink at 21. Or was it actuaries and rental car companies? What age can you rent a car? 25. They knew this long before neuroscientists had a clue. And if you look at the data, it actually is absolutely remarkable because up until 25, there's a really high accident rate, and it then falls off a cliff. It just goes way down. And functional data for how long it takes the brain to develop. In women, it's a few years earlier than it is in men, but basically, when you've got to 25, the prefrontal cortex now play a predominant role in controlling behavior. And the nucleus accumbens of the reward circuit is not so hot. Okay, so what does this have to do with marijuana use? This is an image from quite a long time ago. The first time that scientists were able to see the receptors for THC, that really active ingredient in marijuana, I'm sure you all know that, in the brain. This happens to be the brain of a rat. But all the areas that are in yellow and orange here have high levels of cannabinoid receptors, places where THC is working. And what you can see is they are all over the place. The brain is chock full of cannabinoid receptors. In fact, there's more of them than any other kind of receptors in the brain. They have to be kind of inefficient, so they're not really potent, but still, when we think about the brain and we think about cannabinoids, we know that there are going to be very widespread effects. And we know, as I mentioned in an earlier slide, that they have profound effects on very fundamental brain processes. And you're going to get some very interesting detail from Dr. Friedman in a little while. We also know that the chronic use of marijuana leads to all kinds of cognitive impairments, despite what I said in 1990. It impairs short-term memory, it impairs episodic memory, that is our memory of different things that happen in order. It impairs our attention, on and on and on. And in some vulnerable individuals, it can even provoke schizophrenia and outright psychosis. So there's a lot of things to worry about in this list. And we have to get the question, so, you know, what does this have to do with adolescence? This happens in everybody, right? But, as I just spent 10 minutes telling you about, adolescence is a unique time of development when the brain is pruning itself to set up important connections that will help govern how we behave for the rest of our lives. And it turns out, and this is the title of the study that I found particularly impressive, that you can find it in the net. It receives the National Academy of Sciences. You can get it on the web for free, showing that the younger that people started smoking marijuana, the rate of their impairment. There are things that happen during adolescence that don't happen during adulthood. Exposure to drugs during adolescence has different effects than exposure to drugs during adulthood. And the exposure during adolescence to these drugs, these effects last for a long time, whereas adults are a little bit more immune to them. So adolescence is a uniquely vulnerable period. And one of the things that we now know that marijuana will do is it affects the thickness of the cerebral cortex. Now, I hope you will recall, because none of you were stony or short-term memory is still pretty good, that the development of the cortex is marked by a thinning, right? It gets thinner. And so marijuana alters the thickness. In some places it's thinner, in some places it's thicker, of the cortex, which I think is pretty good evidence that it's altering how the cortex develops during adolescence. The direct effect of cortical thickness, which is a measure of brain maturation, due to the exposure of marijuana during adolescence. So, what's the bottom line? Adolescence is a very critical period for brain development. Adolescent brain is not an adult brain by any spectrum of imagination. We know that exposure to drugs and all kinds of other things during development is going to affect how the brain turns out later in childhood. We know that adolescents are prone to risk-taking, including using drugs, and this is partly due to delayed development of the prefrontal cortex. Marijuana has a profound effect on brain development. So I think the key thing, and it came up very clearly in the discussion you had earlier, is that protecting adolescents from marijuana becomes a crucial task. We face this problem with every other drug as well, but we're now entering a period in which it's become more widely available. And so how we keep it out of the hands of our kids becomes a crucial question. Of course, you all know this issue here now. You could be doing other things that are more fun. But the prefrontal cortex said this is something we've got to deal with. And so you're going to hear a lot more details on all of these kinds of things that go on. But this is fundamentally where we stand in our understanding of how marijuana affects the developing brain and what the implications are. For individuals, the implications are impaired cognitive abilities in adulthood from heavy smoking during adolescence. For society, the implications are more impaired individuals at a time when what we really need